Hi everybody, we're going to talk about hypothesis testing, and I'm going to go through the four-step process in this first one, and then we're going to go through some problems in the second one. And I'm also going to attach the page that I'm working off of, so you'll be able to see that as well, and you can follow along with it as we go along. So we're going to talk about testing about the mean, and the population mean, of course, is mean mu. And for the first part, we're going to talk about large sample sizes, that is n greater than 30. Okay, so we know we always have four steps. We're going to set up our null and our alternate hypothesis, or sometimes we call this the research hypothesis. Either one is fine. The second one, you set up a test statistic. Don't worry, we're going to go through these in big detail, so just hang on. The third, you set up a rejection region. And the fourth step is you draw a conclusion. Okay, and you're saying, oh, why do I have to do that? Well, puppies and kittens can do the first three, but a human person has to actually make the final judgment call. Do I reject or fail to reject? Okay, so let's talk about setting up the hypotheses. And there's really three separate cases to consider. All right, and we're going to go through these. And each of these are really context-driven, and you'll see what I mean in a second. So in the first case that I call case A, our HO is mu less than or equal to some mu sub 0 versus mu sub 1, which is your alternate or your research hypothesis. Oh. Huh. Greater than mu sub 0. Now don't panic when you see those mu sub zeros, please. It's just a number like 4 or 10 or 25. Okay, so you're saying, well, how do I know to use that one? Well, there's some words that you're going to see. Remember I told you these are context driven? You're going to see things like greater than. Okay, test the claim that the mean is greater than 4. Oops, greater than. Sorry, these are run together. More than. Test the claim that it's more than 15. Sometimes you'll say, you'll see increase. Test the claim that it has increased from 6. And so it could be increases, increased. Don't worry about the tense. Just look for the base word increase. And sometimes you'll see exceeds. Every once in a while that rears its little head. Same thing. All right, so look for those words, and that tells you to use case A. The second case, which is case B, that's mu sub 0, my fault, mu greater than or equal to some mu sub 0 versus your mu 1 mu less than mu sub 0. Okay, so it might just come right out and say less than. No subtlety there. Okay, test the claim that the mean is less than 25. Decreases or decreased. Test the claim that the mean has decreased from 50. Sometimes you'll see reduces. Every once in a while that shows up. Okay, test the claim that the mean has reduced from 56. Okay, so like I said, every one of these is going to be context driven. You're going to have to read. Again, for those of you that find these problems tough to read, you're going to have to go through them with a marker if you want to. Pick out the words. Look for the verbs. That's what clues you in on what case to use. Nothing wrong with using. Okay, and then the third case, case C, this is actually kind of a compound case. All right, so you're going to have mu equal to mu sub 0 versus H1 mu not equal to mu sub 0. Okay, and this has a whole bunch of sets of words. It might just come right out and say equal to, not equal to. Has there been any change? Has there been no change? Is it any different? Is it not different? Okay? All these are going to be clues that you go with equals to, not equals to. All right, test the claim that the mean is different from 13.5. Okay, so those are all the kind of things that you need for step 1. All right, and so then you're going to set that up and you'll come back to that in a second. Then step 2, you're going to construct your test statistic. Okay, and that's going to be your Z star. Remember, we're working with large samples. We're going to be using the Z, the standard normal. And that's going to be x bar minus mu sub 0 over sigma over the square root of n, which actually looks just like our beautiful probability formula. Nothing very interesting there. You'll get every one of those pieces out of your problem itself, so you don't have to go looking for those. And the mu sub 0 is just the number on the right-hand side of the hypothesis. Okay, then step 3, the rejection region. Here again, you have to go back into the cases. All right, so in case 1, let's just look at the H sub 1s for a minute, and you've got a greater than there. So you're going to be thinking about your alpha. You're always going to be given your alpha in the story. Okay, so there's your normal curve. And when it's greater than, you concentrate your alpha to the right-hand side. And what you want to do is find that Z where the rejection region starts, that is at the end of the shaded region. So what are you going to do? You're going to take 1 minus alpha. So if alpha is 0.01, you're going to take 1 minus 0.01, and that's going to give you 0.99. You're going to look in the table, in the center of the table, and look for the closest value to 0.99. Okay? Those are probabilities. All right? Probabilities live in the middle, horizontals live on the outsides. So you'll find that probability, then look for the horizontal that matches up. Okay? So in the case of the, sorry, I'm dropping stuff. In the case of the 0.99, the closest hit is going to be 99.01. And if I go to the left, I get 2.3. When I go to the top, I get 0.203. So in that particular case, and again, that's just made up, I would use 2.33. Okay, so each one of these, when you set up your rejection region, you're going to have an if-then statement. All right? So you're going to say if Z star, that is the value that I get from step 2, is greater than that horizontal value that I just found, then we reject HO. So it's going to be if Z star is greater than the Z, that's your horizontal Z, then we reject HO. Okay, good. All right, now let's take a look at the second case. So the second case, case B, in that one, your H1 has your pure less than. There's 0. Okay, so now alpha goes to the left. So I'm going to take that alpha and find the z where the shaded part starts. Now there's going to be something interesting about that, in the sense that that horizontal z is going to be negative, yes? Because it's to the left of 0. Okay, let's just, for fun, pretend I said that alpha is equal to 0.02. Now I'm just going to leave alpha alone. Okay, so I'm going to look in the middle where the probabilities live, and I'm going to look for 0.02, and I'm going to get my little teeny chart. Let's see, 0.02. Oh, where are you? I can't find you. There you are. Okay, there's a 0.202, and that is going to be, when I go to the left, I pick up minus 2.0, and when I go to the top, I get 0.5. So the value that I would use, the value that I would use there would be minus 2.05. Let me erase this here. Sorry. Okay. So the value that you get is going to be negative. So your if then is going to be if z star, the value from step 2, is less than, and it's going to be some negative number, negative z, then we reject HO. Yes? Does that make sense? Hope so. Okay, good. All right. Let's try out the most complex one. Case C. This is very interesting. So in this case, you have two parts to consider. Alpha over 2 goes to the right. Alpha over 2 goes to the left. Now because of symmetry, you're going to find two z values. But because of symmetry, those values are going to be the same. For instance, it's going to be something like minus 1.96 and positive 1.96. Okay? There's 0. Okay, just for laughs, just for hoots and hollers. Suppose I say that alpha is 0.5, 0.05, my fault. And let's do this up. I know I need to find 1 minus alpha over 2. So the first thing I'm going to do is find alpha over 2. That's going to be 0.05 over 2, or 0.025. So I'm going to take 1 minus 0.025, and that gives me 0.9750. That's a probability, remember? Okay? Now I'm going to grab my page and squint because it's teeny tiny print. I have a different one than you guys have in your book, and it's little. Let's see. And there's an exact hit. What a surprise. At 97.50. When I go to the left, I get 1.9. When I go to the top, I get 0.06. So the z is 1.96. Surprise. And then, of course, the minus z would be minus 1.96. Okay? And you finish this up for a second, and then we'll write out the if-then. All right? Write out our if-then. So I'm going to write if z star is greater than z, so that's going to be greater than your positive, or z star is less than minus z, then we reject HO. And the dog just jumped up on my very expensive new recliner. Oh, she jumped off. She heard that. Okay. So that's what we have to do. Good. All right, then finally for step 4, you have to say one of two things based on your answer. You either say reject HO. For those of you that like it, you get to reject the hoe. I knew you were just dying for me to say that. And even better, if you do not, then you fail to reject the hoe. Okay? Now, when you reject HO, just a quick note, you agree with H1. When you fail to reject, you agree with HO. And that's going to be important in a couple movies from now when we talk about type 1 and type 2 error, if you want me to do one of those. Okay? Hope this wasn't too boring, and I hope you found it useful.